Hello. Today we're going to be finding the perimeter of polygons once we've been given the vertices. So basically, the perimeter of polygons that are somewhere in the coordinate plane. For all these sorts of problems, you're going to be given all of the vertices, aka the corners of your polygon, and their coordinates. And so the first thing you're going to do is you're going to graph those coordinates in Desmos. You could graph it by hand, but Desmos is just a whole lot easier, and you don't have to have graph paper. So that's G. If you want to label it G like I've showed you before, you can do that. And then let's get our other 2 points in there. Type in the coordinates exactly the way you see them. Don't forget to get the comma in between. That one is H, if you want to label that. And last but not least, let's enter in our last coordinate. And if you'd like to label that, totally optional, you don't have to. Go ahead and do that. Okay, so we've got our 3 points in there. And so what we need to do here is find the perimeter. Perimeter of any shape, any polygon, is what you get when you add up all the side lengths. So the way that we're going to find the side lengths is we're going to use the distance formula. So we've used distance formula, but just to give you a little refresh, I'm going to write that formula out just so we can see it. That's the one with the big square root, x2 minus x1 in parentheses squared, plus y2 minus y1 in parentheses squared. And so we're going to have to use the distance formula 3 times to find the distance between G and H, or the length of GH, the distance between H and J, or the length of HJ, and then last but not least, G to J. So let's go ahead and do that. So I'm going to start with G to H. So if I have -3, 2 is G, and oops, I didn't mean to write H, I meant to write 2, 2. Actually, let's look at that. From G to H, it's a horizontal line, so we can actually skip using the distance formula, which is a nice thing to do. Sorry about that. We can skip using the distance formula, which is nice if you can. So since it's a perfectly horizontal distance, you can either count the coordinates in between G and H in a horizontal direction, or you can use that ruler postulate that I showed you before. So the 2 coordinates of H that are different are the x coordinates. You're going to subtract one from the other. My HX coordinate is 2 minus my GX coordinate is -3. And so 2 minus -3, absolute value, when I do that, I get 5. If you'd like, you could double check that in Desmos. Type in 2 minus -3, you get 5. So that one was nice because we didn't have to use distance formula. The other 2, however, see how they're diagonal? We're going to have to use the distance formula. So let's try H to J. So I'm going to write out my points here. 2, 2. -1, -3. We'll call 2, 2 x1, y1, and we'll call the other point -1, -3, x2, y2. So then using our distance formula, the distance from the length of H to J is going to be, let's plug those values in. x2 is -1 minus x1 is 2, parentheses squared, plus, now we got to do it for y's, y2 is -3, minus y1, close your parentheses squared. And like we've done before, we can put that in Desmos. So type in the whole thing very carefully, big square root, in parentheses, -1 minus 2 squared, plus parentheses -3 minus 2 parentheses squared, and it gives us a decimal, so we're going to round that, and I'm going to give us a little room to write that here. We're going to say that's going to be, oops, let's do 2 decimal places, 5.83. Now we're going to do the same thing one more time. But so we have G to H, we have H to J, now we need G to J. So I'm going to do my j point first just because I can. J is negative 1, 3. G is negative 3, 2. Just like before, x1, y1 is our first point. x2, y2 is our second point. Let's plug those into the distance formula. Since I wrote my j point first, I'm going to write it as jg. You could do it the other way around, not a big deal. Sometimes when I do my distance formula, I like to write things out first and then just fill in numbers. So starting with my x's, negative 3 minus negative 1. And then my y's, 2 minus negative 3. I'm going to put all of that in Desmos. So big square root. Negative 3 minus negative 1. Don't forget that double negative, parentheses squared, plus parentheses 2 minus negative 3, parentheses squared. When we add all of that and do the square root, Desmos tells us we get 5.39 if we round. Okay, I'm going to get rid of my coordinates just so I have some room to write here. We are actually most of the way done. The last thing we need to do is actually find the perimeter. So that anytime you find the perimeter of anything, we add up all the sides. So my perimeter is going to be just adding 5 plus 5.83 plus 5.39. And as usual, let's have Desmos do the heavy lifting for us. 5 plus 5.83, oop, that's not 83, plus 5.39. Our perimeter is going to be 16.22 units. They didn't specify a unit here. It could be feet, it could be miles, it could be whatever. When they don't give you a unit, we just say generically 16.22 units. Okay, let's try one more. I'm going to get rid of all of my Desmos fun here. By the way, if you ever hit that little clear gear there, you can delete everything, which is pretty slick. This time our polygon has 4 vertices, so let's start by putting all those in Desmos. Negative 4, negative 1, which if we want to label that, that is Q. Keep going. R is 1, 4. Again, you don't have to label, I just think it makes things a little easier to see. S is 4, 1. And last but not least, we have negative 1, negative 4, and that is T. Okay, so good news, bad news. Good news is we can see a nice little polygon. The not as good news, because it means a little bit more work for us, is we don't have any perfectly horizontal or vertical lines here, so we are going to have to use the distance formula for all 4 side lengths. So once again, distance formula like we were looking at in the last problem. I'm going to write it out just so we have it in front of us. Distance is x2 minus, my pen does not want to cooperate this morning, x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to be using that just like we did for the last few problems. So let's start with Q to R, and in the interest of space, I am not going to label my x's and y's. I'm just going to kind of talk my way through it. Let's start with our x coordinates. R's x coordinate is 1. Q's x coordinate is negative 4. Y coordinates. R's y coordinate is 4 minus Q's y coordinate is negative 1. And then let's put that distance formula into Desmos. Square root 1 minus negative 4 squared plus 4 minus negative 1 squared. We get a crazy decimal, which is perfectly fine. QR is 7.07 if we round to 2 decimal places. Let's do RS next. Again, I'm kind of just setting up my equation. I'm going to plug in my x's and y's. All right, SX coordinate is 4, RX coordinate is 1, and then looking at our y's, SY coordinate is 4, RY coordinate is, SY coordinate is 1, RY coordinate is 4. Let's type that whole thing into Desmos. Once again, we get a crazy decimal, not a big deal. Just round it to 2 places. That's going to be 4.24. Okay, and so we have Q to R, we have R to S, we need S to T. So starting with x's, Tx coordinate is negative 1. Sx coordinate is 4. Looking at y coordinates, Ty coordinate is negative 4. Tx coordinate is 1. Let's put that all into Desmos. So square root parentheses. And then just type in what you see. Nothing too crazy here. Notice that's the same as what we got for QR, and that is perfectly fine. All right, and then last but not least, we need to do T to Q, or Q to T, however you want to think of it. I'm going to write it as TQ, because that means we've continued to kind of rotate our way around. Okay, so QX coordinate is negative 4. Tx coordinate is negative 1. Looking at the y coordinates, Qy coordinate is negative 1. Ty coordinate is negative 4. Put all of that fun into Desmos. Don't forget about your double negatives there. We do have to deal with that in both sets of parentheses. And we get 4.24, which is the same as the length of RS. And then we know to find our perimeter, we're just going to add all 4 of these together. So my perimeter is going to be 7.07 plus 4.24 plus 7.07 plus 4.24. And we get that our perimeter is going to be 22.62. They did not give us a unit, so we're just going to say the word units. Notice that because we had 2 lengths that were each, 2 sides that were the same, like what we would call the length was the same on both, the width was the same on both. This looks like it is a rectangle. We'll do proofs with that later down the road. Anywho, moral of the story is, for these sorts of problems, put your coordinates into Desmos just so you can kind of see what kind of shape is happening. Use your distance formula to find the distance between each point, and then just add up all your side lengths. Have a wonderful day.